a roller coaster lift hill. Okay, so this is when a motor takes you to the top of the roller coaster. But after that, the roller coaster does not have a motor. Roller coaster is a gravity machine. That's why it's so awesome to study roller coasters when you're learning about physics, because it's excellent example of conservation of energy and using gravity and learning about different types of other forces. So here we have the maximum potential energy up here, that PE max. Up here, since you stall, when you get at the top, the coaster stalls. There's no kinetic energy then. We're going to say it's minimal. I mean, there is some, but let's just say kinetic energy minimum. Now at the bottom here, right, not when you're leveling out, but once you hit the bottom, then we're going to have the maximum kinetic energy and the minimum potential energy, because now we're on the ground. So that gravitational potential energy is minimum. So we're going to have potential energy is minimum and the kinetic energy is maximum. So potential energy is minimum, kinetic energy is maximum. So about halfway through, you're going to have half and half. So if we think of it as like batteries. We're going to represent the energy with batteries, because batteries actually store chemical energy, and that gets converted to kinetic energy when you close a circuit. Or you flip on the light switch, which really closes the circuit. Is the batteries using the green and red, like they do on the cell phone. So if it's a full power, it's going to be green and we'll have it filled up. If it's red, it's getting low. So we're going to say half or lower. Okay? So we're going to indicate that with the potential and kinetic energy. So at the very top of your hill, this is going to be your potential energy, and very bottom, this is going to be your kinetic energy, right here at the top. So at the top of the hill, if I'm indicating this as battery, maximum potential, minimum kinetic. If I go down here now, it's going to be reverse. So this is kinetic energy is maximum and the potential energy is minimum. So what about halfway down? What about right here? Halfway down the roller coaster, halfway down the hill. Conversion is happening, so it's about half and half. So here then, the potential energy and the kinetic energy half charged. Notice the overall energy in the system is the same. So energy is not created or destroyed. If we look at the beginning, we've got really one battery that's full. The end, we've got one battery that's full. The middle, we have two that are half full. So two half fulls is the same as a full. So the overall energy in the system is the same. The process from going down the hill, though, involves a transformation of energy from potential energy to kinetic energy. So, if all of this potential energy is converted to kinetic energy down here, the maximum potential energy will equal the maximum kinetic energy, which is the case because it's the law of conservation of energy. That's why.